What's up, hackers? Welcome to Saturday Hacker Day. My name is Taggart. It's good to be back on Saturdays after a bit of a hiatus. Well, a week of hiatus. As usual, we're going to be doing some blue team stuff today. Well, kind of some like IT network engineering stuff today. Ted, Grimmy, Lasso, always a pleasure to see you. But as always on Saturdays, we're going to get started with This Week in Cyber, a few of the top stories that I feel like talking about from the week's news. We're going to kick off with Nimbus Pwn, also known as CVE's 2022 29799 and 2022 29800. Now, this one is not the most easy to understand vulnerability, and I think it is also kind of interesting that it was discovered. It's a Linux vulnerability, but it was discovered by Microsoft researchers. Now, breaking this down, what we're talking about really is a component of Network D, which is a newer networking stack that runs on Linux machines, particularly ones that run with systemd. Systemd and Network D kind of work together. And essentially, this is a privilege escalation vulnerability that exploits vulnerabilities in a specific function inside of the Network D dispatcher that allowed for arbitrary file write and a few other tricks. It's so in the weeds that it's almost not worth taking a look at it in this particular format. But the TLDR here is go patch your stuff. This is a really interesting vulnerability, and it's also interesting to see the levels to which Linux security research is getting. I think that there's more and more attention being paid to it now that we know that attackers are also focusing a lot more on it, especially with the advent of ransomware that targets, say, hypervisors, which often run Linux. Speaking of Microsoft research, there was another story. This is from the research firm Wiz, although it's targeting Microsoft Azure. And what we're talking about here is exploitation of Postgres or PostgreSQL. I never really know how to pronounce this software, but that allows for cross-account database access. And it's kind of a two-parter. This is a little bit strange. Excuse me. The way that the write-up works, it kind of fudges the initial access component of it. So basically what the researchers did was that they spun up Postgres SQL instances in Azure. And then what they did was, we found another vulnerability that gave us remote code execution in the Postgres stack, which has since been patched. So they said, okay, RCE, and then let's ignore that and move on. So once they had remote code execution on the virtual machines that were running the SQL instances. And by the way, let's back this up for a second. When we're talking about cloud resources, right, obviously you can just spin up a virtual machine in the cloud, right? And it'll work just like a virtual machine in a local hypervisor to a first approximation. But other services that are offered by cloud service providers like Azure would be things like managed databases, where it's like, okay, well, you don't have to spin up a whole server to run a database. We'll handle that for you, and you can focus on the database, and you can configure backups and replication and whatever else you want. But we're going to abstract away the whole computer that the thing is running on for you. But there is still a computer that it's running on, even when you choose that service. And that is what these researchers exploited and were able to get remote code execution on, was that abstracted away computer that is still spun up. Just like how a couple weeks ago we were playing with GitHub Actions, right? And GitHub Actions build code from GitHub repositories. Well, it has to do that somewhere. And what we found was we got a reverse shell off of an Azure virtual machine that was spun up specifically for our build. Same concept. So once remote code execution was achieved on this database virtual machine, they discovered that there was a set of certificates that they had access to, and a set of essentially access rules, access control lists that said if the certificate matches a specific regular expression, then then allow access. And as it turned out, the regular expression that they used had a wild card at the end of it after the Azure websites.net stuff that you're supposed to have on it. And so what was wild was that the attackers were able to buy a certificate for a domain that they controlled, the first part of which matched that regular expression, and the last part of which was their own domain. And because of that regular expression wildcard, for whatever reason, placed in the access control lists. In fact, according to the write-up, they basically just said, I'm trying to find the quote, but it's basically like, this is a mistake. Like, this should not be here. Yes. Why does this regular expression end with dot star? This is clearly a mistake. Could we register a domain that matches this regular expression, generate a client certificate for it, and then use that to log into our server by impersonating the replication user, which was one of the users that had an Postgres access control list assigned? The answer is yes. So that was what that vulnerability was really about, was this use of these certificates and wildcard expressions to match them. This has since been addressed in Azure, but it is one of those things where I think it, again, is really easy to think that cloud managed services are hardened for security purposes before they are deployed to the massive internet that they serve. And we're seeing time and time again that that just is not the case. And that as much as these services are abstracted away, they are absolutely vulnerable to many of the same kinds of issues that more legacy types of systems would have been vulnerable to, because the underlying technologies are still the same. And to editorialize just for a second, this is always a concern that I have when we're talking about cloud services, is that if your entire IT team focuses on cloud services as they are presented by the cloud service providers, and you don't have any of the expertise in the underlying technologies, you're likely going to miss some stuff. And that's exactly what we're talking about here. All right. Last thing that I want to talk about, and if I lose some viewers for this one, I'm sorry, but I do feel like it's important to talk briefly about the Twitter thing. And before I do that, Slayer Darth, Mr. Orion, and Zedis, thank you so much for the follows. So I feel like we need to talk about the Twitter thing, in part because of the outsized role that social media network plays in information security. That's just a reality of how it goes. And what we're talking about specifically is what things are going to look like after Elon Musk, if Elon Musk successfully completes the purchase and the takeover of Twitter. I have significant concerns, but I don't want to just talk about my concerns with Musk, because that's not particularly original territory. But I'm going to talk a little bit about my usage of Twitter and what the last week has made me think about it. Grimmy, he bought Twitter, but he's also violated the terms of the purchase like immediately, and the purchase has not fully been approved. And I think there's some SEC stuff that has to go through as well. There's a lot of debt that he's taking on to try to make the buy. So the offer is in, but I don't think it's fully complete. So the truth is that a lot more of my life than I'd like to admit is tied up with the Bird site. And in part, that's because in a very real way, my InfoSec career was kicked off due to it. Leslie Carhart, aka Hacks for Pancakes, they were kind enough to send me a ticket to HOPE, Hackers on Planet Earth, in 2018. And that's where I fell in love with the industry and decided to pivot my career in this direction. That wouldn't have happened if I hadn't been on Twitter. And so I have to be realistic about the role that social media network plays in this industry. But the idea that a free speech absolutist is going to take this network and mold it in his image, and is talking about some things about trust and safety and the like real name policies and absolute free speech policies that we know cause more harm than good from years of research on this. I'm very concerned about what's going to happen to that and what's going to happen to the people that I care about who use that platform. But again, I want to kind of segment that off from the bigger conversation, which is that because of this upheaval, it got me thinking a little bit about how I use social media, how I use Twitter, and what it does to me and what it makes me care about. And I also have to acknowledge that in my heart of hearts, I am pretty skeptical of social media as a business. And I fully admit that there's some hypocrisy there saying that on Twitch, which is a social network and that is monetized, and I'm happy for your subscriptions. I'm not going to discourage that. But I have to be skeptical, especially about something like Twitter, where what I see and what I am asked to engage with is driven by profit motives and is driven by a fight for my attention. At the core of it, I'm troubled by what businesses want me to see and care about. And I realize that my attention is being taken and shaped in that way. And I know that that's probably not super healthy. So to consider the counterfactual to that, to consider the alternative, I reactivated my Mastodon account, which I've had for a couple of years, but I haven't really used it. And if you're not familiar with Mastodon, it is an alternative social network that is built on the ActivityPub protocol. It's all open and it's a federated network, meaning that anybody can spin up a server. You can have users on your own servers, but that the users of those instances can then connect with users of other instances to kind of build the network that they want to see. It doesn't present itself as easily to you as Twitter does, but there's some good and some bad. There's also no algorithmic driving of content, right? What you ask for is what you get, no more, no less. The truth is that in my heart, I believe in free and open solutions, especially for connecting people. And when I started using Mastodon, yes, obviously the user base is way, way smaller, but in a way it felt good to be using something that I know was powered entirely by people. And the use of Mastodon revealed things that are worth thinking about, at least for me. So, for example, Mastodon hides their equivalent of likes and retweets from posts by default. You can't see them unless you really click into a post, but they're not presented to you readily. And I actually think that's super healthy because you stop caring about them so much. You put the content out there that you say what you want to say, and it's not so much about caring about how it's reacted to beyond actual replies. But you're not after these made up metrics. Now, you also have to seek the content that you want. It is a little bit more challenging to find people to follow and get people to follow you. That's a process. But the work does reward you with connecting with people that maybe you wouldn't otherwise have done. And also maybe that work isn't so bad because it creates a more, I think, organic connection, if such a thing is possible. And there is also a global feed that allows you to see all sorts of folks, especially if you follow things like the hashtag introduction, that you would never have seen. You'd never have encountered these people and their point of view if you hadn't been doing that. And certainly any algorithm wasn't going to feed that to you readily. And I think there's value in that. I believe in diversity of thought, with exceptions for intolerance and fascism. Now, that said, by and large, the vibe that I've gotten on this network has been incredibly positive. I've had a couple of pretty gross people I've had to block, but you block an entire server for people who are free speech absolutists, and basically Nazis, because that's how the internet's going to work, but you can curate that out, and it's not so hard to take care of that. And what I've found is that this usage of social media doesn't feel so much like a competition. Now, maybe that's not your experience with it. Maybe that's just me. Maybe that's part of my type A upbringing. But I found using Twitter, especially more recently, that I started caring more than I wanted to about what the engagement was with the stuff that I posted. And feeling like when other posts got more engagement, that was some sort of reflection on me. And that's sick, right? That's not okay. But I don't have that feeling outside of Twitter, and I don't have that feeling on Mastodon. So I feel less surrounded by anger and anxiety. And that maybe that's temporary. But at the very least, experiencing the alternative has made me rethink how I use social media. And regardless of what happens with Musk, regardless of what happens with Twitter, I feel like thinking about what good social media as it is does for us is worthwhile. So I'm not going to hard sell you on joining the Fediverse, which is what the social networks like Mastodon and PixelFed, which is like open Instagram. I'm not going to hard sell you on joining it, but if you are a Twitter user and if you're concerned about where things maybe are going, or you're concerned about what it does to you, I do think you might want to give it a try, or at the very least, maybe take some time away from the bird site and see how it feels. And then maybe if things do break bad with Twitter, you'll decide that maybe you're not so comfortable giving a megalomaniac or his attention-craving apparatus your mindshare. So I'll just end this little editorial with, if you're interested in this, you can find me at on the Fediverse at mttaggart at fosstodon.org. Fosstodon is the Mastodon instance that's focused on free and open source software, which was really my first love in technology, which is why I decided to join that rather than an InfoSec focused one. But I follow a lot of folks who are on the InfoSec focused one. So if you're more interested in general, you can go to joinmastodon.org and you can find a server that fits you. So if you're interested, I'll see you there. All right. On to the actual thing that we're doing. We're doing network segmentation, part 2 today. And we're going to finish the build out of our flat network, which is pretty much done. And then we're going to do some actual network segmentation to make this a much more secure environment. So we're going to be working in Cisco Packet Tracer today. And if you missed part 1, but it's definitely on YouTube, so you can go check that out. But let's get started. Okay, it does look like there may be some extra questions about Mastodon. So, what server was the InfoSec focus for Mastodon? There are a couple of them. I think that the one that I'm seeing most and that is currently active is, and the one that I know that Lasso is on is IOC.exchange. Yes, IOC.exchange. That also seems to be the most populous one at the moment. So you can check that out. Or, infosec.exchange, my bad. Infosec.exchange. So there's a few, right? And if you go to joinmastodon.org, they'll actually, if you put in your interest, they'll point you to a server that may be appropriate for you. Okay. With all of that out of the way, let's take a look at our network as it stands. A few new things have happened here, and I was just playing with it a little bit before the stream to get us up and ready to run. So let's kind of zoom out and talk about where we are right now. So this is our general universe, we have Los Angeles, and then we have the internet. And the internet is kind of represented by this stuff up here. In fact, let me draw a rectangle around it. What we'll do... There we go. So this is the internet, and then we are separating it with a fiber modem. I changed it from a cable modem to a fiber to make it a little bit more realistic. I'm having some weird routing issues with this router right here, and I'm not sure why, but whatever. The purpose of this is to, create an internet simulation, and we're getting close to it. But we want to focus internally first. Now, this view of the network isn't super helpful at the moment, so let's talk about where things are physically. We're going to go to Los Angeles, and then we're going to go to Taggart Tech HQ, and this is kind of the build out of our environment. So we have the MDF, or the main distribution frame, and this is where the internet comes into the building, basically, right? And I apologize. I should have given a warning. I apologize for the cable management. I cannot control it. That is something that Packet Tracer does. I cannot change this. I wish that I could. Hey, Zav, thank you so much for the follow. But, so what do we have coming in? Here's our fiber modem. And what's going on with the fiber modem is basically we have two fiber interfaces. One of them is the external IP address, right? 100, I mean, in fact, it's a router, but whatever. But we have an external IP of 100.200.100.123. And we have an internal IP address of 10.1.0.1. And so that's our inside-outside, okay? We then have a 24-port switch right here, some of which we're using, some of which we're not. And currently just a single VLAN. Hey, Orbital, thank you so much for the gift sub to Angel. Really appreciate that. We have the Midnight server, which is kind of an internal server, 10.1.0.2. This is providing DHCP, I believe, on our... Yep, this is providing DHCP on our flat network right now. And we're naming servers after synthwave bands. That's what we're doing. We have FM84, which is our wireless LAN controller. So if we go to our wireless LANs, you can see we have Taggart Wireless. And we're just doing WPA2 with a pre-shared key of Taggart Tech. It's not a good password, but that's kind of the idea, right? We're trying to build this wrong. And then we have a wireless access point in the MDF, which might sound crazy, but I actually love having that because I don't like not having wireless access while I'm in the server closet. It's a huge pain. And then I just put in Wolf Club, which is a web server that we're going to route out to the internet eventually. So that's kind of what's in the MDF. And then we have an IDF, an intermediate distribution frame, in the business office, because the business office has its own special stuff, right? And so this is another 24-port switch with a fiber crosslink back to our core switch, and some other devices connected to it, and Gunship, which is the business office's file server. Here's our wireless infrastructure. You can kind of see that we have some laptops and some other devices that are connected. We have wireless access points. We have one in these two classrooms, Classroom A and Classroom B. We have a break room, and we have some phones that we haven't configured yet, but we have some phones in each area. And I was just before we got started setting up printers. And of course, they're wireless printers because they're so reliable. Whereas the guest network, there's always a guest network with Rogue mobiles or laptops. We haven't set up the guest network yet. But you are right. But we're going to add a printer for the business office as well. Now, there is no printer in my office. I'll let Husky speak for himself if he's hanging out. There's no printer in my office because I have a religious objection to printers. I'll never use one. And these printers should connect straight away. Let's take a look at the logical diagram. Customer A, and then the business, we'll put that over here. Wireless 0, SID, tag wireless, WPA to PSK. Looks good. That should be connecting. Unless we need another wireless access point in the business office, which we might. So we'll put another WAP in there. And this one is kind of cool because we can connect it to the business IDF. That'll be WAP 5. No 3D printers. They don't count. 3D printers are fine. Although, the problem is that I've had to maintain too many of them. You know, I've had to, like, actually replace extruders and do service on them and calibrate them at scale. I don't know why. I think it's because I had to do this for so many kids for so long, for you know, in schools. But yeah, 3D printing doesn't, like, turn my crank. I respect people who get into it and enjoy it, but like it's not my thing. Similarly, hardware hacking, it was never my jam. Do not like soldering. Do not like Arduinos. Again, I respect it, but it's just it doesn't excite. My particular version of broken is that I prefer building out network architectures like this rather than designing like a robot. All right, so we have to connect that wireless access point to the business IDF. So let's go back to our logical here and see if we can find WAP 5. Where did you get to? There you are. WAP 5 will connect you to the business office. And this thing should get configured automatically and start serving data. I will literally buy new ink cartridges to print something. The next time I need to print, it will be dry. Inkjet printers are a scam. I mean, all printers are a scam. But inkjets in particular, like your cost of ownership of an inkjet is so much higher than a laser printer. Bite the bullet and pay the initial higher cost for the laser printer, even for a color printer. It's so worth it. If you need to do printing of any kind. All right, this thing should be on. Let's look at our wireless controller. I wonder if it can't cross. Oh, there it is. WAP 5 just came on board. Does toner go bad? Not like on a particularly long time or particularly short time scale, because, okay, quick aside for people who have never had to deal with printers. First of all, you're the luckiest people ever. Toner is a solid. Okay, it's a powder. And what happens is that the laser essentially melts the toner onto the page. Laser printers are a wild two-step process. Step one is that the printer is statically charged. Or I'm sorry, the laser doesn't melt it, the fuser does. So step one is that the laser statically charges the paper in the pattern that you're trying to print. The toner then sticks to the paper in that pattern because of the static charge. And then the part that gets hot, the fuser, melts the toner into the paper so that it sticks to the paper. And so because it's a solid, it doesn't really go bad the same way like ink cartridges can dry. Now, there is artificial toner going bad, I should say, because a lot of times there will be chips on the cartridges that have a built-in calendar, basically, or a counter for days. And if the current date is exceeded past a certain point, like there are hacks for this, but there are kind of artificial lifespans for toner cartridges, which you can get around. And also there's an amazing aftermarket for like refurbished cartridges, which is worth looking into if you do a lot of printing. The Lone Ranger, thank you so much for the follow. All right. Why are my printers not getting wireless? Let's look at our laptops and see why they are. Tigert Wireless, WPA2 PSK. Is the interface not on? The interface is on. No, you really can't trust printers. Confusing. What did I do differently here? That all looks correct. Lap 5 is up. And these are in the classroom, so these should have wireless access the same way that the laptops do. That is curious. Of course it's the printers that are going wrong, right? Just absolutely of course. Oh, is it because we have bad... hold on a second. No, this is the AC module. Okay, let me power cycle it, see if that does the trick. This is N internet. I wonder if... No, because I made sure that these access points were AC. It's always DNS. We actually aren't running DNS just yet in this environment. But okay, so one thing I do want to talk about, since we're talking about segmentation, is right now all of this is flat, right? And printers being connected or not, notwithstanding, although that is annoying. this should not be flat, right? Let's think about the kinds of devices that we have on this network and how we might want to break it down. We can break our network down either by classes of devices or by organizational units, right? So we have the business office, obviously, which I might kind of do a little bit of a draw around here. Let's do a fill for that. Oh, that's so pretty. Ugh. All right, so here's our business office. Maybe we'll do like a cloudy situation for it. Yeah, there we go. Okay. So there's the business office, right? And then here we've got like management. Right? The stuff that Husky and I are using. Should probably exist in its own kind of universe, right? We have a public server that we know that we want to put out on the internet, but right now we haven't done that, and also there's no defense between it and the rest of our network, so that's problematic. And then, of course, we have our wireless stuff. Let's go like turquoise for that. We have our wireless stuff, which is, you know, a unique kind of terrible. And these are, you know, devices that should be connected via wireless, right? We have our classrooms, which may be a separate thing. Again, we're just thinking organizationally at the moment. Just put the RDP server on the public and be done with it. Yeah, exactly. And then, of course, we have these IoT devices, which I don't even know what to do with those. Well, I do know what to do with those. Put them directly in the trash, but I can't get rid of Husky's espresso machine. I'll be in trouble if I do that. And then, of course, we have devices, right? We have core backbone devices, right? Isolate them. But that's what I mean, is that we have to think about these organizationally. And then, of course, we have our phones, which, let's go green for phones. Right? There's a phone here as well. So that's kind of the trick, is how do you want to consider your network? How do you want to isolate devices? And I want to be super clear about segmentation. When we talk about segmentation, we'll talk about VLANs and we'll talk about subnets, but those by themselves are not gonna do it. Shouldn't we, careful with the shoulds, but we do as with outfacing entry points, isolate and just open what needs to be accessed. Angel, I think you're gonna have to go into more detail with that. And don't forget that, again, we're talking about this from the position of a network engineer. So my job first is like, okay, I got to get this office working, right? The servers have to be up and running. The business office has to be working. They have to be able to get their jobs done. And then we secure it, right? But if I secure it so hard that work can't get done, I've actually failed as an engineer and a security professional. Remember, confidentiality, integrity, and availability. If you are so confidential and you're so integral that there's no availability, you messed up. So question for the chat. Do we want a quick aside, just a breakdown on how subnets represent in an environment? Sure, why not? Okay, well, since we got no other... Okay. I am going to get out of here. And we're going to come down here. We're just going to make a brand new... And I'm going to go physical, and we're going to get out of here. And we're going to make a new site. I actually love this. This is so fun. We'll just make a new building. And we'll put this down... Put this down in El Segundo. This is kind of close to where Silicon Beach is. This is where, like... Google has its offices and things like that. So we'll call this the test lab. And in the test lab, we're just going to put a new rack, a new closet. Call that lab MDF. This is like the most fun piece of software. And in the wiring closet, we'll create a new rack. Venice Beach, so we can get Wi-Fi from the beach. Santa Monica has Wi-Fi too. I don't know why you would trust it. Create a new rack. Okay, so we're gonna do something very, very simple first. We're gonna start with a simple switch, and we're gonna do network devices. We're gonna do a PT switch, just a switch. PTMD. Good, just like that. And we have a choice of what kind of interface we add to it, because there's nothing in here. So let's add a gigabit Ethernet, right? Copper. Oh, I gotta turn the power off. There we go. There we go. All's well. Go. There we go. Okay. So now we're gonna add 2 computers. And I'll set up a table, I guess, for that. Okay, there's a table. Just setting up a PC. And where's my... There we go. Put one of these here. And put another one over here. Cool. The reason I wanted to do that was because I want to actually interact with both of them. Okay, so good here, and we're just gonna make a connection, a copper connection. Boom. So, yeah, let's actually talk about the public Wi-Fi thing, because it's not... I'm not concerned about person-in-the-middle attacks so much, really. Well, I am a little, but not the way that we usually talk about it. It's not like, oh, you need a VPN because somebody in the coffee shop is going to spy on you. No, not really. My concern with public Wi-Fi is that I don't want to have to, like, give away my email address, and I don't want to have to sign up for stuff just to use public Wi-Fi. And I don't want my telemetry going through hardware that I don't necessarily trust, especially in small places where I don't know what kind of hardware they're running in the back end, right? An ISP is a little bit different than even a municipality that may not be configured in a way that I like. So that's my rationale for trying to stay away from public Wi-Fi. It's not about fear-mongering. It's more just about where do I want my packets traveling, even if they're TLS, because it's entirely possible, especially if it's a large organization, that they have a assigned cert root CA, and they can in fact get your stuff. Okay, so we have these two machines connected. So basic subnetting. We're gonna configure this first. We'll make this one a 192.168.1. We'll call it 10. And we'll put it on a /24 network. You're guessing most municipal Wi-Fi isn't going to break TLS. That's probably true. But I'll tell you something else. A lot of times the public Wi-Fi is provided by ISPs that I don't feel like dealing with either. It's not a universal. But like, why do I don't know. If I have a good connection through my 5G or whatever, why risk it, right? Okay, so this is 192.168.1.10. And then this is going to be 192.168.1.20. So, as of right now, these two machines are on the same subnet. Okay? And the switch is more than happy to allow these to connect. I hope, unless I've done something stupid. But we'll give it a shot. So I'm on 20, so we'll do ping 192.168.1.10. Ha! Oh, why is that true? Because this thing needs to be powered on. So that's for starters. Okay. All right, switch is up. Let's go back over to our desktop 10 here. We'll try ipconfig. Okay. Ping 192.168.1.20. And we got a reply. So again, we didn't have to configure anything on the switch, right? The switch is just like, okay, packets go here. And we have interconnect between these two devices thanks to this switch. Now, if I change over our second machine to be on the 192.168.2 subnet, keep in mind that this subnet mask means that in terms of what the subnet is that's available, these bits are masked off, and a 255 means all of the bits in that octet, this section of the IP address, are masked off. So by changing it from a 1 to a 2, I've now functionally put this machine on a separate subnet from our original, the 1.10. Okay. With that done, let's confirm that that's true now. Okay, 2.20. Let's go back over here. And let's try our ping again for 2.20. Now I can't touch it. Because why is that true? Because, let me get my drawing up a little bit. My drawing tools. Cool. Okay, so when devices are on the same subnet and I send a packet to the switch to say, hey, what's up? No routing really has to happen because the switch is going to be like, or actually this is going to make an ARP request out in the subnet and say, hey, what MAC address corresponds to the IP address that I'm asking for? And then somebody's going to respond, right? This machine's going to respond, and then cool. Then we come over here. But in the event that they're not on the same subnet, the way that routing is supposed to work is that you have to have a default gateway. And right now, we don't have a default gateway, right? We just have a static IP address. There's no default gateway assigned. And so in order for that to work, we have to create a router to handle things. So, let's make separate subnets work in this environment. To do that, we're going to add a network device. And we're going to add a router. And I'm just adding these empty routers, basically, because I'll move this down here. Router up top, switch below. And we're going to change up the router's config here, because this thing comes as a mess, and we don't need any of this. Don't need this, don't need this, don't need this. I want gigabit Ethernet here. Thank you. Thank you. Okay. Now, we'll power this back on. And we're also going to have you know what? So, I'm trying to think here. This still is good. Yes, I need to power this off. And put on another. Like so. Two of them, actually. All right. So, our router is now going to look like this. The first one we're going to do is 192.168.1.1. And it correctly guessed that I wanted a /24 network for that. And then here we're going to do 192.168.2.1. Same deal. So these are my default gateways, right? This is where if something is exiting the subnet, this is the device that it's supposed to go to. Yeah? So we're going to connect those, the copper straight through. And we have to turn these on, right? Yes. Good. Okay. And these are still all connected. Now, we've got two machines on the same switch, but now we have a router that's also here. Now, let's see if this changes the equation. It doesn't, but also, hold on a second. Yeah, because to set up the default gateway. Yeah. 192.168.1.1. Good. And we'll do the same thing over here. The default gateway is 192.168.2.1. If we go to the IP config, Now, see we have a default gateway. And let's confirm we can hit the router. 192.168.2.1. Nope, we can't. Sucks. Okay. These are on. What did I do wrong? Yeah, the switch is powered on. Look, we have green lights. We should have link. Oh, God. Lasso, you're right. The switch was not powered on. That would help. There we go. Now we're getting link. We should see blinky lights, and we weren't seeing blinky lights. Good call. Okay. Let's try that again. Although still no on this. Oh, we haven't done the full negotiation yet. These need to turn green. There we go. Hey, there we go. Now we're getting somewhere. Okay. I had a moment where I was like, did I forget how networking works? That's going to make the rest of this stream really complicated. Okay. So we have the two machines here, and they're on separate subnets. Now, I want question. Let's see. We'll do a poll for this. And we'll do that for just a very quick poll, 2 minutes. I'm asking, can these two machines currently communicate in their current state? They're on, we have two separate subnets. They're all connected to the same switch. And they are connected up to a router, which has different interfaces. Right? Okay, 1 vote for yes. Hey, Owen Codes, good to see you. And the program that we're using is called Cisco Packet Tracer. It is free. You do technically have to sign up for an account with Cisco to use it, but that also is free. Yes, Twitch can in fact do polls. I used to have an add-on that does them, but all right, looks like it's unanimous so far that yes, they can in fact communicate. All right. Looking like we should give it a shot. So 2.20. The truth is that that's kind of router specific. This one is not allowing cross-interface routing. Chill Crunch, this doesn't watch packets on local networks. It creates networks in a simulator. So all of this is simulated. It's not real. Okay. So right now, we do have network segmentation, but it's because the router itself is configured to not have cross-interface routing. We can set that up. But if we do this, like, look, if we do 2.1, we can see 2.1. But 2.20... Oh, I'm just an idiot. Sorry. I don't know why that didn't work last time. It did work. It just took a second. My mistake. So this is actually, the router is configured as I would expect in default, which is, yes, they can. So everybody was right. Because the router is doing what routers do. They're saying, hey, I know this subnet, and I know what interface I'm supposed to send these packets to, and I'm going to send them to them. Send them to it. That's exactly what should happen. Now, can we prevent it? The answer is yes. To prevent this at a subnet level, we have a couple of different options. At the router, we can prevent it. We can also set up a firewall between these that would prevent it if we don't want to do this on the router. But the router should also allow us... go to the CLI here. Yeah, we can do an access list. And we do a deny address to match. You do 192.168.1. Does this take? This doesn't take. Citer does it. Yeah. It's been a minute since I've done this on a Cisco router. Luckily, oh, here we go. So what we'll do is we'll go into the right interface. So what do we have here? Show int. What are our two interfaces? One of them is okay. Gig 0 is the 1 dot, and gig 1 is the 2 dot. So if I go into t int gi int gi 0 0, this will be a deny from 2. So we'll do. Oh, my bad. Dang it. It's not there. It's at the global level. So we'll do access list. 10. We're gonna deny 192.168 dot 1.0. Wildcard bits. So the wildcard bits is like 0.0.0.255. It's like a reverse of the mask. Hey, Anonymous Cheer. Thank you. I'm sorry. It's been a while since I've entered these commands, but what we're doing is we're creating a deny list. And so we're saying deny 192.168.0.0.255. So the entire one dot network here that we set up on that interface. What we're going to do is we're going to deny that to 192.168.2.0, and then again the wildcard bits 0.0.0.255. Now that's at the whole router level, but that's not really where I want to do that. I want to do it at the interface. All right, we'll do some more research into that, but when we're ready to do it. But the idea that I wanted to specifically call out was that without specific configuration, additional configuration, your router, if it is not physically separated, okay, well, there's another part of that we can talk about, but if there's not some other layer of separation between these two gateways, the router is going to just route the traffic. Okay, so subnets alone are not network segmentation, I think is the point that I really want to get across here. Now, after subnetting, the other component that we start thinking about is something called VLANs, virtual local area networks. And these are... I'm trying to see if we can find a good diagram. Actually, yeah, that's pretty good. So, as you may know, this happens at the Ethernet layer. And when we talk about network packets, right, think about the OSI network model. Let's actually look that up too. And I always like the mnemonic, please don't nuke the same place again. Although, wow, you know, recently that one is less fun, isn't it? But these layers of the OSI model, they don't... And people do need to see Paula Abdul. I like that one. But one of the things that we like to talk about is that these network layers are like onions, and when we create network packets, the layers are wrapped around each other, meaning that the application, right, the HTTP itself is like encapsulated within presentation, encapsulated within session, right, within all of this. So when we look at how VLANs work, there's a specific component of the Ethernet part of the packet frame. And these are just like sequences of bits, right, which determine the shape of the packet. And inside of that, in fact, let's see if we can do like a packet diagram. Nice. That's a good image. I wish some of these would load better. There we go. So we're here at the Ethernet layer, okay? Before we get to, so the network contains the internet layer. The internet layer, see that data? That becomes this, then the transport, and then that becomes the application, okay? And so when we look at the Ethernet frame, inside of that, there's an actual additional kind of encapsulation, this tag, right? The 8021, actually, it should be 802.1q, not 1.q. 802.1q, that tags with the VLAN identifier. And basically, it's a way of taking a single physical network and creating metadata about the packets at the Ethernet layer to distinguish how the traffic should be treated. Now, in order for this to work, you need to have switches that are .1q capable. Most switches these days are, but that's just something I want you to be aware of, that you do need to have that capability in order to make this work. And I should mention that something you may run into are devices that are not VLAN aware. Like endpoints can be, but it's kind of a pain. And even like little tiny switches that you get to extend your network, like a tiny Netgear switch to take one access point or access port and turn it into multiples, they may not be VLAN aware either. And what happens is if you take a VLAN aware switch port and you put a VLAN unaware device on the other side of it, the tagging gets stripped. So you no longer have that VLAN data on the other side. So just something to be aware of when we're dealing with VLANs. Now let's see how VLANs work in practice. And this is something I spent a lot more time working with, even than subnets, really. God, why is all this open? Okay, so let's kind of burn this down. And rebuild this. We're going to disconnect the router, actually, because we don't need it for this particular part of the conversation. And let's also put this back on the same. All right. So we're going to make it the same gateway, and then we're going to give it 1.20 again. Okay. So now we're once again back on the same subnet. Okay. Let's look at the switch config and take a look at, actually, let's look at it this way. Hover over it. Look at how this thing is configured. It shows us a little bit about how the switch looks. We have Some ports, the 2 other gigabit Ethernets 6 and 7 are down because we just disconnected those cables. 8 and 9 are up. And then there's this other interface called VLAN 1 that says it's down. What is up with that? So VLAN 1 is the default VLAN, at least on Cisco switches. It's, if you're not actively using VLANs, that's what every device is on VLAN 1. Now, if I wanted to give this switch presence on this network, I would actually activate the VLAN 1 interface, give it an IP address, the whole smash. And that would allow me to interact with the switch as a network device on that VLAN. But I also have the ability to create other VLANs. And attach switch ports to that VLAN. So pretty straightforward here. We're going to go back to the CLI, I hope. And I know that's really small. I don't think I can zoom that in, unfortunately. But we're going to enable to gain root on the switch. We're going to do conf-teak to configure terminal. And then we're going to... What comes next? Oh, yeah. So if we do a question mark at any point, by the way, if you're playing along with Packet Tracer, you just do a question mark and get answers about what we have, and VLAN commands is what we want. So we want VLAN, and then we get to create a VLAN here. So let's make a VLAN 10. Okay. Now we're configuring a new VLAN. Look at that. Okay. We'll do name alpha. Okay. And then we'll just exit. And then we'll do VLAN 20, name Bravo. Okay. And let's exit, copy, run, start. And then show it. Or show. We should have show VLAN, right? Yeah, show VLAN. Check it out. We now have VLANs 10 and 20 available on this switch. We're not doing anything with them, but they're there. And look, it says that the VLAN 1 is used on these switch ports. I am going to switch over port 9, yeah, to use VLAN 10, and port 8 to use VLAN 20 to correspond with our 2 different IP addresses. Okay? So to do that, I think I can actually do that. Yeah, I can do that here. Oh, no, I can't. I have to do that in the CLI. Nope, my bad. I can do it here. Hooray! So I'll show you how we do it. So for port 9, it's an access port. Now, access ports and trunk ports are terms that you'll see when we're setting up switches. What are access ports? What are trunk ports? Access ports refer to basically everyday switch ports, plug something in, it works, single VLAN. Trunk ports are designed to carry multiple VLANs across them. And I'm asking you, what are some reasons why we might use a trunk port? In what situation might we use a trunk port? Anybody? Bueller? To join VLANs together. Kind of. It's often to join switches together. So let's say that I have this switch here that has VLANs 10 and 20 configured, right? And I know that I have a couple of devices on this switch that I want on VLAN 10 and a couple that I want on VLAN 20. And then let's say I have another switch someplace else in the building, but I also want to use those VLANs there. But my core switch here is the one with the uplink to the internet or whatever. Well, I need that VLAN traffic to make its way over to the switch that has the uplink. And I may, in fact, actually need it to get up. The router may, in fact, need the virtual interface with a VLAN as well, depending on how I configure it. But either way, I need that VLAN traffic to cross a single interface, right? A single NIC or a single network interface on that switch. Exactly, so you can run one cable rather than multiple. So what I would do is I take that interface, whether it's fiber or whether it's copper, and make it a trunk port. And the trunk port then can carry multiple VLANs worth of traffic across it. And that is basically what you would do when you create a distributed switching environment. And then the switches have some ways of like figuring out, there's this thing called VTP, or VDP, I think, where if you set up your network, your switches correctly, creating a VLAN on the master switch will then filter those down into your subordinate switches. I know master's not like a great term anymore, but I believe that's still the term in the CLI. So we're going to switch over this switch port to use access port to use VLAN 10. And then this one we're going to switch over to use 20. Okay, and you can see down here that what I would do is configure the interface and then do switch port access VLAN 20. And that is how we make sure that that data is tagged as VLAN 10 and 20. Okay. Looking good. Now we'll go to the command prompt here. Now this device is not VLAN aware, but nor does it have to be. The whole point of an access port is that data coming out of that switch port and elsewhere in the environment or elsewhere in the switch is going to get tagged. So as it leaves the device and goes through the switch, it gets the VLAN tag attached to it, basically. That's how access ports work. Now, I, into 168.1.20, will fail? Yes. In this configuration, the connections will fail. But if we have inter-VLAN routing enabled, that will not be true. So, what might that look like? Let's go back into the switch and so we'll do int VLAN 10. We just created VLAN 10 by doing that. We made an interface. and then we'll give it an IP address even. Let's do, or we'll wait on that. Int VLAN 20. Exit. Copy runs. Exit. Copy run start. Let's hover over the switch again. Behold, I now have VLAN 10 and 20 interfaces. That show up. Now I still don't have interlink between them. And that's because right now, the switch doesn't have any routing capabilities. Really, it has switching capabilities, but it doesn't have routing capabilities. Right? So, but I can enable inter-VLAN routing on these switches to allow one VLAN to communicate with another. Now, I hate doing that, but I also know that sometimes it's necessary, especially if I'm using VLANs for organizational splitouts rather than device-type splitouts. So, for example, if I have a printer VLAN, or if I mix and match, right? So if I have a printer VLAN and I need the business office and the HR or whatever, if I need both of them to be able to access the printer VLAN, then I obviously need to have inter-VLAN routing enabled. That is a break of network segmentation, right? You will never have perfect isolation across your environment. That's something to just be aware of. And you have to take that into account when you're designing your network. How do I want my network to be designed? Do I want to do a logical grouping, or do I want to do an organizational grouping? All of these things come into play. We're going to knock we'll leave this alone actually, because it doesn't hurt anything. We're going to come back up here. So with that in mind, I'm curious, chat, how are some ways that you might split out this network that we need to isolate here? We have our business stuff, we have the wireless stuff, we have these printers that still aren't playing ball for whatever reason. Yeah, radio's on. No ideas about how to make these connections happen? Yeah, no, that still worked just fine. I love that the printers just don't connect at all. That's actually perfect for printers. All right, well, if we don't have any guesses, The first easy one that we should do is isolate the phones. That's just like basic stuff. And the reason you want to do that, it's not even a security thing. It's like a quality of service thing. So basically, if you're using IP phones, you want your call quality to be as high as possible. Okay? In order to do that, and by the way, VoIP phones, that conversation is UDP, right? So it's streaming data. And so those packets, right, unless they have top billing on the switch, they may get dropped in favor of other packets. How do you fix that? Well, you need to somehow identify the packets coming from phones and say, these are the most important, never drop these. And that's how you kind of maximize your call quality on those phones. All right. We don't have to go into like the details on how to set up VoIP quality of service for this, but we do need to set those phones aside into a separate VLAN so that they can actually get their connection. So to do that, we have to configure some VLANs. So let's go into our core switch to start. Oh, look at this VLAN database. This is so much easier. Let's go ahead and make a VLAN. I like putting them up towards the top. I like doing like VLAN 80. We'll call that VoIP. Awesome. Good, good, good. And then we can specifically assign anything that is connected to, oh god, this navigation is so weird, to one of those. So let's see. Oh, these did get IP addresses. That's fun. Okay. This one didn't. That's on, seriously, 101? 9. No, I want 7. You can configure stuff more than more than one interface at a time. Sorry, took a while to get out. 7 and 8. Okay, well, 7 and 8. We're going to switch those over to being on VoIP. Okay. And let's make sure that these are all configured the same way. We actually have a phone config here. Let me unplug it and reconnect it. This one's on port, what? 1, unbelievably. So this one also has to be on VoIP. Okay, cool. And I'm going to unplug it and power it back on. That's literally how you do that. Okay, now let's take a look at this switch over here. It does not have VLAN 80 yet. Because we need to enable VLAN trunking protocol. So we're going to go back to our core switch, and going to do config here real quick, and conf. Okay. You can see that we should have a VTP mode. Yep. VTP mode server. It already is the VTP server. Then we got to check this out, and you should be VTP mode client. There's one other thing that we need to do. In order for VLANs to communicate across this fiber line, this fiber line needs to change shape a little bit. It's gig 112. This guy right here is no longer an access port. It must be a trunk port. And we're saying, okay, it's selected to be, we're going to trunk 1 and 80 and the FDDI. These are the VLANs allowed on that trunk port. We have to do the same thing on this side. Gig 111. Gotta be a trunk port. And it still doesn't have VLAN 80. So we might have to manually add it. For now, and see how that does. Now we have the VoIP VLAN available on both of these switches. Okay, we're up. And notice how in gig 111, you can see those two dashes there. That indicates that it's a trunking port, that there's no single VLAN that it's assigned to because it's carrying multiple VLANs. Very good. Now, for these phones, we're also going to do gig 103. Okay. So 103 gets VLAN 80. And 104 gets VLAN 80. Awesome. Now, these phones do not have actually they are VLAN aware. Yeah, configuring VLAN. Yeah, phones are weird. Or Cisco IP phones are weird. They have a 10100 PC port that allows you to like actually pass through a 100 megabit connection to a computer. Don't do that. And then it has the switch port uplink. And by default, it's on VLAN 1. Computers are weird. I find the phones to be super weird. But these are now like on the VLAN 80 network. Now, it turns out that you can set up DHCP on the switch if you want to. Which can be useful for things like phones where you may not really care what the static IP is. But I prefer to have my DHCP servers separate so that they're more manageable. I let my switches do switching and I let servers do serving, if that makes sense. So what we'll do is we will copy Midnight here. And we will name this... Oh, you know what would be a perfect one? We'll name it Kavinsky. And if anyone knows why that's a good pun for the VoIP DHCP server, let me know. Now, this is a trick that I like to do. Keep in mind, the reason we went through the difference between subnets and VLANs is to make sure that it was clear that they are different. But I like, personally, wherever possible, to use subnets to identify VLANs. So, meaning that this thing is this thing is going to be on the .80 subnet, and its IP address itself is going to be 80. And that tells us that we're going to use, for me, if I'm creating a network like this, if I can get away with, /24s, 23s, whatever, it gives me a little bit of an idea of what my network looks like at first glance. This doesn't work perfectly depending on how your network is structured, but for something that is the right sized, it's very nice to be able to look at an IP address and say, not only do I know what subnet that's on, but I also know what VLAN that's on. That is crazy handy. All right, so Kavinsky is doing DHCP for us, and we'll call it the VoIP pool, and default gateway is 80, and the start is going to be 80.10. That's fine. Oh, right. So 10.1.80.1, and the start is going to be .10. Phenomenal. Okay. And so we will... Where is this? Presumably it's in the... Oh no, Kavinsky, you gotta be... You need to be not there. How do I move? I honestly don't know. How do I move this thing out of the location? To move a device, use the navigation button, highlight the device, and drag it to the new location in the tree. So I need the location tree, which is here. Ah, okay. So I will put this on the MDF rack. I can't do that. Oh, I see. I have to go right. Kavinsky, you come up. I didn't want to move it to the internet. Oh god, that sucks. That's so annoying. Okay, I think that'll solve my problem here if I can move it to the rack. Good. Hooray! Woof. That could have been a better user experience. Okay. Kavinsky, where are you at? There you are. Okay. So Kavinsky, we're going to connect to this switch. Now, at this point, I might, if I were building out this network and I had the funds to do so, I might make a separate switch for phones. If I could. Just because it's nice to have a physical distinction for this stuff. I mean, this can get kind of messy. But for now, that's fine. So we're going to take this port here. Michael Muma, thank you so much for the follow. Okay, we're going to power this machine off. And then we're going to do a connection. There's a reason why we're doing that. I'm going to connect it to 19. Okay. And then, boom, gigabit Ethernet there. Okay, now our switch 19, you are on VLAN 80 for VoIP. Fantastic. Now, our router doesn't have an interface on VLAN 80, right? Or the 80 subnet. So we can either create a virtual interface or we can do a physical. In this case, because we've got the gear, let's just do a physical. So this will be a gigabit Ethernet. Yes. Oh, turn the router off. We'll do a gigabit Ethernet here. And turn you back on. And we will do a copper connection to 17 to here, but then 17 also VLAN 80. Okay. And then for here, we'll call this 10.1.80.1. So now we have DHCP for our phones, in theory. Kavinsky is off. Let's turn it back on. And this is on VLAN 80. And these phones should be getting their DHCP in a second. And they should also auto-configure to recognize that they're on VLAN 80, not VLAN 1. Oh, 80 is... I gotta turn all these ports. Oh my god. Dang it. By turning it off, the config didn't save for the router. That's unfortunate. So 9 is my external, right? So that's got to be 100.200.100.23. Okay, turn that on. And then this should be 10.1.0.1. Good. Still no DHCP. Kavinsky, are you running? Service is on. 10.1.80.10. Looks good. Okay. 2. The VoIP phones were state of the art. Yeah, they were. Ping 10. Let's look at our IP config on the server here. Okay, ping 10.1.80.1. I just want to make sure I can see it. I can. And let's also confirm that I can't see anything else. 10.1.80.2 or .0.2. So I don't have inter-VLAN routing enabled right now, which is exactly what I want. Right? So my two VLANs cannot communicate at the MO because I want my phones to be isolated. But I also want them to have do I have to power cycle the phone? Very funny that I have to do all of that in the simulator. That's the real deal. Is there a hard reset on one of these? I don't think you can hear that, but it is in fact making a dial tone. Let me power this off and power cycle one more time. If we can't get the phones to phone, whatever, we did the networking component correctly. There we go. It says configuring IP. Okay, so now we can also do wireless. So let's make VLAN number, let's say 50 for our wireless LAN. Default wireless LAN, right? Okay. VLAN, so 50 is in our VLAN database. And I similarly am going to need DHCP here. Now, this is a situation in which I can use my wireless controller to do DHCP for me, and that isn't the worst thing in this particular case, right? So first of all, I'm going to set up my wireless LAN to make this VLAN 50. This is going to get a little bit tricky, though, as we'll see in a minute. Because in order for this to work, well, I wonder if anybody can maybe troubleshoot this. In order for me to use VLAN 50 for my wireless, what do I need to do to make for my wireless controller to make that actually work in my network as it is? I'll let you noodle on that for a second. Nobody? We're about to break wireless here in a second, but I actually don't know if I want to do this. On here. Because I don't want it to be on the... management interface. These wireless controllers are a little bit funky. But I do want this... Ooh, no. I do want this to be on VLAN 50. So the answer is that in order for this to work correctly, this communication here if it's going to provide VLAN, then this has to be a trunk port. This has to be a trunk port that carries. We'll do 1 and 50. I said trunk port. Thank you very much. And we don't want it to carry VoIP, right? Because there's nothing on that that requires the VoIP VLAN, so leave it off. Okay. And now, if we want a different DHCP pool for VLAN 50, we're going to have to do that. Let's do that actually over here on Midnight, right? Which is going to handle DHCP for our local area devices. So we're going to power this off. We're going to give it another gigabit Ethernet port. Power it back on. And then we will give this a 10.1.50.2 address and services DHCP. This one we don't have yet. I'll call that WLAN pool 10.1.50.1 and 10.1.50.2 would be this here. 10. Good. Okay, WLAN pool. Yeah, gig Ethernet 0. Good. Turn that service on. Oh, thanks, my only wife. Glad you approve of the hair. I got it done at nowhere. And then, in order to really make all this happen, we're going to have to trunk all the wireless access points as well. So you can see already that this really gets super messy. This isn't even a large network, is it? But we have to do all of this in order to make our communications work and do the segmentation the way that we want. This is why network engineering gets so complicated, and frankly why they get paid well, or why they should. Now, actually, just kidding. These should be access ports on port 50 for the access port, and the VLAN should be 50. The reason being, yeah, 120, that all of their traffic is just going to be WLAN traffic, and we actually don't want it to carry VLAN 1. But now we've introduced a bit of an interesting complication. 20. Oh, hey, GoPro. Glad to see that you're alive and kicking. 22. Oh God. I know. Dude, I was out of town last week, which I can say now. And yeah, same deal. I flew out with a mask mandate, and then they dropped it while we were out of town, which was terrifying. Yeah, big no thanks to that. Yeah, look, if you are traveling, if you're doing anything really in public, look, COVID's not over. Please, 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 do not stop wearing your mask. It's important for people who are interacting with immunocompromised folks. It super matters. So please continue to mask up as appropriate. I know it's not fun. I don't like it any more than anybody else. But I do believe we have a social responsibility to protect those who need extra help. Matthias, and ourselves, frankly. Because I don't know about you, but I'm not about catching that long COVID. Let's add 50. Lathering my whole body in ivermectin won't work. No, it won't. Nor will any of the supplements that you bought from Alex Jones. Sorry to say it. 'Tis the truth, though. All right, what port is this on? 5. You are going to 50. Okay. Ooh, and you need to go to... Did we do this? 3. Did we do this right? Yes, we did. It's hilarious that the printers are still not working, despite being configured correctly. Honestly, A+ work from the printers. Thank you so much for being you. Now, you... Oh, Midnight needs another switch port, doesn't it? We need a copper straight through. Do 18 to here. Gig 0. Okay. And then, yeah. Sorry. And then over here, 18 has to be on VLAN 50. That's why we were getting IP addresses. Okay. So... we have to like power cycle all of these, but oh wait, my bad. No, we don't. It's power over Ethernet. What we have to do is go to the interface. I was like, what's happening? What's the easiest way to do this? It's probably killing the switch, right? Yep. This isn't safe. Don't do this in real life. Yoink. Good night, core switch. Oh, I might have just burned myself too, if that config didn't save. Nope. Awesome. Very cool. Yeah, 18, you've got to be on VLAN. Oh, it did save the VLANs, but it didn't save the switch port configs. Well, that's going to suck. 24, are you trunked? Nope, you are not trunked. $23. You should be on 50. Lesson learned. Always, always, always copy run start. 20. Okay. Maybe there's a paper jam. That's awesome. Okay. Let's run the CLI here, and let's go to copy run start. No, exit. Copy run start. Cool. And let's do the same thing again. We're going to power cycle the switch because this thing already caught wrong IP addresses. Ooh, let's see if this is trunking. 112. 112. You are not trunking. Crap. You need to be trunking. Yeah. Yes, that's good. You need to be trunking everything. And I think that's pretty much it. We got our wireless access points. This was still good. This was still trunking. Let's also copy run start down here. Switch configs. How much fun. I actually do think this stuff is fun. I know that it's not the best viewable material, but this is, to me, like getting all this stuff configured is super, super exciting to me. I don't like real-time strategy games, but this is my version of real-time strategy games, is figuring out how to build out networks so that everything connects the way that it should and that it's secured. Matthias, the challenge here is we're talking about network segmentation. Hey, we got proper IP addresses. So let's see, AP groups. Yeah, this ain't gonna work. Because the should be on 50. See, the management should be on 10.1 and 0 to 10, but we need another connection on 50. So let's do a copper straight through. 16. No available ports. What? It can only connect to the management port? So this is a simulated network, and I am trying to demonstrate network segmentation concepts. That's what we're talking about here. And yeah, the tool is Cisco Packet Tracer. We're going to have to change this up a little bit, though, unfortunately. Yeah, it's going to be 50.10. 50.1 is the default gateway, which we don't have yet, but it's fine. And what was this on? 24. 24 is going to have to be an access port on VLAN 50 to make that work. And that's a limitation of the wireless access controller. And these should come back online at some point, because we should see, because we have these with, oh, not this one though. 20 is on VLAN 50. So we can do no shut, or shut it down, and then no shut to bring it back up. The reason we need to do that for wireless or wireless access points is because the things are power over Ethernet. So if I need to do a power cycle, I have to do it from the switch or manually unplug it, which is exciting. WAP 4, you're on 20. Yeah, that just happened. So you should be coming up in a second and starting to give access. You 21. What's your deal? 21. All right, you're on 50. Let's go to shut. No shut. I love how you turn things on as no shutdown, negation of the shutdown. It's very funny to me. And we are seeing AP's access points come back on. So the wireless is working. People are happy. This one, 5. Do the same deal. No shut. No shut. How are you looking? Yeah, no. 22, you should be... You're on VLAN 50, but let's restart you. Shut. No shut. Oh yeah, so I should mention that we do cross-post to YouTube for any new viewers. Come on. Hey, there we go. We got 10.1 to 50. So our wireless came back up, and now we have a separate... This is kind of exciting. Maybe I mean, if you're still hanging out, I'm hoping that you're finding this exciting. But we now have a separate VLAN for our wireless from our wired components. And we have a separate VLAN for our phones, in theory. Oh, we got to get those off as well. 1. Crap. 1, 7, 8. So 1, you should be on VoIP. 7. You should be on VoIP. And 8, you should be on VoIP. Now watch this. I hope I remember how to do this. There is a cool way to do this. Int gigabit 1 0 GI 107 8 or 101 comma GI 1/0/8 or 7-8. No. Oh, I can't do comma separated contiguous. Okay, so we'll do shut, no shut. Okay. And then we should be able to do ranges. So if I wanted to configure both 7 and 8 at the same time, exit. To let's do it that way. Come on. Fine. Shut. No, shut. I really thought there is a way to do a range. I don't know why I'm forgetting the syntax. Shut. No, shut. Awesome. These phones don't have an IP address either just yet. 3. Yeah, you're on 80. Should be on 80 as well. Kavinsky. What's your deal? You're on 19. That's your deal. You need a DH. You need to be there. We'll shut you down. No, shut. Bring you back up. Okay. So, all right, let's take a look at this a little bit. So, I've got a server, Midnight, here. No, Midnight is... here's my tag serve. This is me. 10.1.0.4. Okay, now, from one of these laptops... see, from one of these laptops that doesn't have an IP address yet. Oh, because the... Oh, wait, did I lose... 102? Yeah, dang it. I lost the... Go. I lost the DHCP server there. Now we're good. The DHCP server has the right VLAN. Start. Let me turn this off and turn it back on. See how it does. Boot P. No. Yeah, the WAPs are good. The laptops are not getting... Oh, this one is, weirdly. What's your story? And we should see, yeah, these are all online. The signal strength of an emulated network. No, it actually does matter because there's a physical component to it as well. So if I put like obstacles in the way, it would in fact matter. This purple that you're seeing here is actually the wireless coverage. If I turn that off, it'll be like no wireless coverage. They are massive access points, by the way. The way that I've scaled this out. Like, I obviously didn't do this to scale because the access points appear to be covering most of mid-city Los Angeles. Which is not accurate for a building, but it's fine. All right. So it's coming up on 12:30. Wi-Fi trubs notwithstanding, what we've done here is we've done a basic network segmentation. So we have different subnets for different logical groups and different VLANs for different kind of organizational type things. So for example, I've got phones on a VLAN that matches their subnet, but I have all my phones on their own VLAN. I have a wireless VLAN. I would, if I wanted to break this out further, I would do an IoT probably, separate those out. And then one thing that we still haven't done, we may do this at some point. I kind of wanted 2 sessions to be enough of this for right now, but what we should do at some point is figure out the firewall and DMZ here, so that this web server that ideally we want connecting to the internet, this should not be in the same network with these other servers at all. In fact, it should be isolated with a, if not a physical switch, it should be isolated with a firewall, right? Now, we should have a firewall also coming from the internet, but the DMZ should have yet another layer on the other side so that we can control what comes in and out of that server. Obviously, we have to manage it some way, but we need to be able to isolate it however much we can. But yeah, I think that's a good intro to some of the concepts of segmentation, and I think next week we'll get back to some more specifically blue teamy stuff and leave this for now as it is, unless anyone has specific questions and something we can dive into. It was fun kind of going back to network engineering for a little bit. But for now, oh, well, okay. Kind of seems like cheating, but it looks like Nahamsec is streaming, so we're gonna go ahead and raid Nahamsec, which I've never done before. That's kind of fun. So, friends, thank you so much for hanging out. I will be back on Tuesday with Attack on Tuesday, doing some red teamy stuff. Wednesday for programming, and of course next Saturday for blue team. Yep, and so let's go enjoy some NahamCon. Until next time then, please be good to yourselves, be good to each other, and I will see you next time. Happy hacking.